Hello everybody and welcome to the next part of my Spigot particle effect tutorial series. In this part I'm going to be concluding the 3-part series on creating a particle effect that moves between points. And in this part I'm going to show you how to create this particle effect right here, which actually curves very nicely along the points and doesn't have any jagged corners. And now this is the part of the tutorial where I would normally show you a diagram about how the math works for this particle effect. But this one is significantly more complicated than the previous two, so I'm going to skip that. But if you do want to look more into it yourself, I will include the Stack Exchange link that I used to help me build this math down below. And you can also just go ahead and Google piecewise cubic interpolation curve, and that should show you more information about how the math behind this actually works. But with that being said, let's just go ahead and hop right into the actual code. Now, as usual, I will be writing all of the code for this particle effect in this run effect method. You can essentially just copy everything I write in here and paste it in your own program wherever you want. And I also created this project that allows me to type in a command along with a particle effect name, and it will play that particle effect for me. So if you are interested in learning more about this project, I will include the GitHub repo for it in the description below. Now with that, let's go ahead and actually start writing some code in here. So first off, we just want to create some properties. And now the first one is just going to be an integer called speed, and I will set this equal to 1, and this will basically just be the speed our particle effect will move along the line. The smaller the number, the faster it will move. And then we will create a double, and I'll call it approx dist between particles. And then I'm just going to set this to be 0.25. You can set this to be whatever you want, but basically it will be the distance in blocks between all of the particles that will spawn. And now we're also going to create an array list here of locations, and I'm just going to call this particle locations. And I'm going to set this equal to a helper method that I will be creating in just a moment, and I'll call that getParticleLocations. And then we're going to be passing in approx dist between particles here. And now before I continue on with this, I'm just going to go ahead and write this getParticleLocations method. And now just a heads up, I'm going to be jumping between methods quite a bit, so just kind of follow along and keep a close eye on which method I'm currently working on. But let's go ahead and create that method. So it's just going to be a private method, and it will return an array list of locations. And then we'll call it getParticleLocations, and then we'll pass in a double called approx dist between particles. And we'll be creating some properties in here as well. The first one will just be an array list of locations, and we'll call this points list, and we'll set this equal to another method that we will be creating in just a moment called getPoints. And now I'm going to go ahead and create this method real quick. So this will be just a private array list of locations, and then we'll call it getPoints, and then it won't take any parameters. And what this is basically going to do is, in order to do our curved particle effect, we have to have at least 4 points. So what we're just going to do here is, if our curve is made up of less than 4 points, we're just going to do some little hacky things to make it so our particle effect can still run as long as we have at least 2 points. And so all we have to do in here is we just want to do if points.size is greater than 3. And now here, underscore points is just an array list I created that contains all of the points that I want my particle effect to travel through. So whatever container you use for your points in your particle effect, you will just insert here. You can see up here, I just have an array list of locations called points. And so now here, if this is true, all we want to do is just return points, because it already has at least 4 points, and so we don't have to do anything to it. Otherwise, if points.size is equal to 3. What we want to do here is we want to create a new array list of locations. We'll call it new points list, and then just set that equal to new array list. And then we're going to be passing in, or adding, we will be adding first points.get 0. And then I'm just going to copy this and then paste it 3 more times. So we have 4 total things we're adding. Then we'll be adding points.get 0, points.get 1, points.get 2, and points.get 2. So we'll be adding that final point twice. Then next up, else if points.size is equal to 2. All we're going to do here is we're basically just going to copy this, paste it in, and then we're just going to do 0, 1, 1, 1. So we will be adding in the 0 point once, and then the 1 point 3 times. And then we don't need an else if or if point size is equal to 1, because if there's only 1 point, there's no line to travel along anyways, because it's only 1 point. So now all we want to do is we just want to make sure here we return new points list. And same thing in here, we want to return new points list. Now here at the bottom, we are just going to return null, so that basically if points is of size 1, we're just going to return null because it won't work for our particle effect anyways. So now we can go ahead and return to our getParticleLocations method up here. And then we want to add in a couple more variables here. The next one is just going to be a double array. We'll call it distances, and we'll set this equal to new double, and we will make the size points.size. Now we'll create another double, just call it total distance, and then we'll set that equal to 0 initially. Make sure you spell distance right. Now the first thing we want to do here is we want to compute the length of all line segments. And all we have to do for this is we just want to loop through all of our line segments. So we'll just create a for loop, call it int I equals 0, while I is less than distances.length I plus plus. And then in here, we're just going to set the distance of this particular segment we're looping over, and we'll set it equal to pointslist.get I dot distance of pointslist.get I plus 1, and that gives us the distance between these 2 points for this line segment, and then we're just going to add this to total distance plus equals distances of index I. And now we have the distances of all of our line segments, as well as the total distance of all of our line segments combined. And so now what we want to do is we want to compute the particle count, or the approximate particle count. So we're just going to create an integer. I'm going to call it approx particle count. And we're going to set this equal to total distance divided by approx distance between particles plus 1. Now you just want to make sure you cast this first section here, total distance is divided by approx dist between particles, to an int, and then we want to have our semicolon. Basically all this does is it just computes the total number of particles it will take to create our line, and then we just add 1 to ensure we'll have at least 1 particle. And now we want to just create an array list of locations, and we'll call this particle locations, and we'll set this equal to a new array list. And now what we want to do is actually compute the locations of all of our particles. Now it's going to start to get a bit more complicated from here. Again, I'm not going to explain the math, I'm just going to run through all of the code. So for this, we just want to create a for loop. We'll create an int, call it segment, set it equal to 0, while segment is less than distances.length, then segment plus plus. Now in here we want to create an int, we'll call it particles in segment. So we're just going to compute the number of particles that is in this individual segment along our line or our curve. Then we'll just set this to be equal to approx particle count times distances of this particular segment divided by the total distance. And now we also want to just be sure we cast this to an int. And now this gets us the approximate number of particles in this segment. And so now we just want to create another for loop, do int point equals 0, while point is less than particles in segment, point plus plus. And this is just going to loop through all of the points that will be within this individual segment. And now in here, we're just going to create a double called t, and we'll set this equal to point divided by particles in segment. And now you just want to also cast point to a double. This just ensures that we get a double returned and we aren't just doing int divided by an int, so it's always going to be 0. We want to make sure we get a double in return. Now t is basically just going to be a double between 0 and 1. The closer to 0 it is, the closer to the first point it will be, and the closer to 1, the closer to the second point it will be, so on and so forth. Okay, now we are actually going to compute the x, y, and z position of all the particles we are going to spawn, but this also depends on if our segment is earlier or later in our curve. So what we want to do here is we want to create an if statement. So if segment is less than 1, what we are going to do here is we're just going to create a double, call it x, set it equal to another method, and this will actually be the last method we will be making, I promise, and it'll just be called compute interpolation. And now, before I populate this, I'm just going to go ahead and create this right now real quick. So we're just going to create a new method called private, and it's going to return a double, and we'll call it compute interpolation. And it's going to take in a handful of parameters. It'll take in a double called P0, another double called P1, another double called P2, another double called P3, and finally a double called T. Now in here we are going to do a bit of math. Again, I'm not going to explain it, just going to write it out for you. Double DERI equals 0.5 times, then in parentheses P2 minus P0, and then double DERII, set it equal to 0.5 times P3 minus P2, and then double A0, just set that equal to P1, and then double A1, set that equal to DERI, and double A2, set that equal to 3 times, then in parentheses P2 minus P1, then minus 2 times DERI minus DERII. Then we'll create another double called A3, and this one will just be equal to DERI plus DERII plus 2 times, and then in parentheses, negative P2 plus P1. And then we are finally going to return A0 plus A1 times T plus A2 times T plus A3 times T times T times T. Now, I'm going to double check I did all this math right. 0.5 times P2 minus P0, 0.5 times P3 minus P2, P1, DERI, 3 times P2 minus P1 minus 2 times DERI minus DERII, DERI plus DERII plus 2 times negative P2 plus P1, and then A0 plus A1 times T plus A2 times T plus A3 times T times T times T. Okay, now just double check for yourself that you also did this math right. Now we can go ahead and go back up to our get particle locations method here, and then we're just going to fill this up with a bunch of stuff. This is just going to be very repetitive, so double check that you are filling in everything correctly, please, because this is where a lot of errors could pop up. So first in here, we're just going to do points list.get0.getx, and then we'll give it points list.get0.getx, and then points list.get1.getx, and then points list.get2.getx, and then finally we'll give it t. Now we're going to do the same thing for y and z, so I'm going to go ahead and just paste this in, and then first here replace all of these x's with y's, y, and then replace this one with z's, get z, get z, get z, get z, confirm we replaced all of our x's with y's and z's where necessary. Very good. And now we can actually add this particle to our particle locations. So all we have to do for this is just do particle locations dot add, create a new location, and then we will pass in points list dot get 0.get world just to get that world reference. Then we'll give it x, y, and z. So now we're going to do a few more variations of this if statement here. The next one is just going to be else if segment is equal to points list dot size minus 1. So we're going to be doing something very similar to what we did up here. So I'm going to go ahead and just copy all of this, paste it in here. We're just going to be replacing a few things here. So here, instead of points list.get0.getx, we are going to replace this 0 with points list.size minus 2. And then all of these three, this 0, 1, and 2, we're going to replace all of these with points list.size minus 1. So I'm just going to copy this little bit here and just paste this in with this 1 and 2. And then we'll do the exact same thing with our y and z here. I'm going to get this points list.size minus 2, stick that in here and here, and then we'll get our points list.size minus 1, and then just paste this into all of these, our 3 for our y, and then our 3 we have for our z, and just double check, everything looks good. Yep, everything looks good. So now that's all we need to do for this variation. Next up, we want to do else if segment is equal to points list dot size minus 2. So in this variation, I'm just going to copy again what I did up here, paste it in here. So it is within our else if statement we just wrote. And then what we want to do is we want to, in our x first off, with our first point list.size minus 2, we're just going to replace this. So instead of being minus 2, it is minus 3. And then this first point list.size minus 1, we want to replace that with minus 2 instead. And then we'll just keep these two as 1 as they already were. And we'll do this exact same thing for our y and z. Just replace this with 3. And this one with 2, this one with 3, and this one with 2. Now finally, we'll be creating our last variation here of all of this busy stuff going on. And so for this one, again, I'm just going to copy all of this, paste it in here, and then what we're going to do is we're going to take this points list dot size -3, clear all of that, and then we're going to replace it with segment -1, and then same thing with these. We're going to replace it with segment, then the next one we'll replace it with segment +1, and then this last one we'll replace with segment +2. Now we'll just do the exact same thing for our y and z variables, just segment -1, segment +1, and segment +2. Now same thing with our z, segment -1, segment +1, and segment +2. And now that we have this, we can finally go down here, and after our 3 closing brackets here, and before the 4th one, we're just going to return particle locations. And so finally, all of our helper methods are done, and we can return to our run effect method up here. And this is also where it starts to look a lot like the previous tutorial videos. So here we just have get particle locations stored in particle locations, and this just contains the location of every single particle that we are going to spawn. And now the way I wrote this, we basically pre-compute it when we create our curve, and then anytime we want to run the particle effect afterwards, it is just going to reuse this array list of locations, so that way we don't have to do all of this computational power every single time we want to spawn our particle effect. But now that we have all of this, we can actually go ahead and spawn in our particles. So all we have to do for this is just new bucket runnable to create our bucket runnable, have our curly brackets here, and then just run task timer. And the first parameter is just the plugin instance, which will be your specific Java plugin instance. For me, that is just _plugin. And now for the delay, we want 0. And then for the period, this is where we will use our speed variable we created, so that it will spawn a particle every, for me, 1 tick. And now in our bucket runnable, I'm just going to have IntelliJ automatically create my run method for me. Going to just reformat it a little bit how I like it. And now one more thing that I personally like to do is I like to keep track of the task ID of my runnable. I just have it stored up here as an integer called _task ID. It is an instance variable for me. You don't have to do this or keep track of this. I just like to do it just so I don't have to cancel all of the particle effect or the scheduled events that are happening within my plugin instance. So what I'm going to do for this is I'm just going to go ahead and take _task ID and assign my new bucket runnable to that task ID. And then at the end here, I just want to do .get task ID. So that way it is not returning our new bucket runnable instance, it's returning our task ID. And now that we have this all set up, we can go ahead and create an integer within our bucket runnable, but outside of our run method. I'll just call it int idx, set it equal to 0 initially. And now in our run method, we want to update the index of the particle we're currently spawning. So just update idx. So all we're going to do here is we're just going to check if ++idx is greater than or equal to particle locations dot size. And if that is true, we are just going to set index equal to 0. That way it is just going to loop through our curve over and over again. And when our index reaches the last particle location, it is just going to loop back and set the index back to 0. And so now above this, we are actually going to finally spawn in our particles. And all we have to do for this is I'm just going to create a double called x, and I'm going to set that to a particle locations dot get idx dot get x, then double y equals particle locations dot get idx dot get y, and then double z equals particle locations dot get idx dot get z. Now we have our x, y, and z position. We're going to be spawning our particle so we can actually spawn in our particle. So we need to get our world instance. The way I just do that is particle locations dot get 0 dot get world, and then just do spawn particle. And now you will give it the particle you want to spawn. I'm going to make it look like the example particle I had earlier, so I'm just going to set the first one to be composter. And then we will give it the x, y, and z coordinates that we want our particle to spawn at. And then finally we will give it the number of particles we want to spawn. I only want to spawn 1. And then optionally you can also give it an offset. So I'm just going to set this to be equal to 0. And the last thing, just to ensure it looks exactly like my example, I'm going to spawn in some additional decorative particles. The first one is just going to be Crimson Spore, and then the second one is going to be Falling Obsidian Tear. And then for this one, I actually do want to give it an offset. I'm going to be giving it an offset of 0.5. So I'm just going to set that to all of these here. 0.5, 0.5, 0.5, and 0.5. And now with that, all of the coding is done. You made it through it. Good job. So we can go ahead and hop right into Minecraft and check out the final product. So here we are back in game. I can go ahead and test out the particle effect. Now the way I set it up with my plugin is I can just type in a command CPE and give it the name of my particle effect, curved line. And then I can just go ahead and set all of the points that our particle will spawn at. Now that I assigned all of the points, you can see our particle effect is looking exactly how we want it. Now, if you're wondering what happens here when it starts to go underground, and that's basically just because the particle effect also curves in the Y direction. So when it reaches this point, it's just going to curve a bit down so it can end up curving upwards just to make it look a bit nicer and smoother. Now, there are a few things you can do to kind of fudge how you want your particle to move and travel. For example, I could add in another line right here, and it would basically just do what it does here, where it goes underground and then goes back up. However, one way I can cheat this is I can actually add in a second point in this exact same spot. And so if I add an additional point a little over here, you can see that when our particle effect actually reaches that point, it won't go underground. It's just going to stick to the floor. And it does give it a little bit of a jagged edge. You could kind of play around with it by giving a little bit more distance in between those 2 points. But it's just a good way to kind of fudge it a little bit if you do want to minimize the curving effect at certain portions of your curve. And now if you want to create any of the unique versions of the particle effect that I created in the very first line tutorial, I won't be including that in this video, but you can basically follow the exact same process and it will work the exact same way. But with that, this will be the end of this tutorial video. I hope you found it helpful, and if you have any particle effects you would like me to try to recreate or any ideas yourself that you would like me to create for you, just leave them in the description below, and I would be happy to make that into a video for you. Now, thank you very much for watching. I hope you enjoyed, and I can't wait to see you in the next tutorial. Goodbye.